Shambhunath Group of Institutions, shaping the future.
Good morning. Today's topic is series and parallel operation of SCR. Why we have to connect SCR into series or parallel? Series is used where high voltage is required, while parallel connection is used where high current is required. Now suppose the rating of one SCR, if the rating of one SCR is 3 kV and 200 ampere approx, and we have to use this SCR for an industrial load or in a power system where the voltage is approx 33 kV. If this high voltage is applied across a single SCR, then this SCR gets damaged. To avoid this failure of SCR, we have to connect a several SCR in a series connection so that each SCR can share the voltage like this. We can connect n numbers of SCR in series to avoid the failure of SCR. Now this source voltage can be divided into all these SCR and it can bear its rated value. So if a source is a voltage, then we have to connect this SCR into series. If the source is current, then we have to connect these SCR into parallel. This high value of current is divided into all these four SCR. Okay. The performance of this SCR can be judged by its efficiency known as string efficiency. String efficiency of SCR. String efficiency can be defined as the total voltage of all the thyristor, total voltage of all SCR connected in a string to the number of SCR, which is equal to n, and the rated value of individual SCR. Now take an example. If a string has a voltage of 33 kV and each SCR has a voltage of say 300 volt and there are 6 SCR, then its efficiency is equal to 33 kV, that is the total string voltage upon number of SCR, which is equal to 6, and the rated value of individual SCR. Individual SCR rated voltage is equal to 300 volt. This determines the string efficiency. efficiency of whole system. Okay, there is an example in the book which says that total string voltage is equal to 3300 and individual voltage is equal to 600 volt. The individual voltage is 600 volt. Total string voltage is 330 volt and it connects 6 SCR. That means the total voltage of all SCR connected in series, the total voltage which is equal to Vs, the total voltage of all SCR connected in a string, that means Vs, total voltage connected in string, which is equal to 3300 volt in the given example. Now number of thyristor is 6 and rated value of individual SCR. Rated value of individual SCR, that means there are 4 SCR. Suppose this SCR has a rated breakdown voltage of V1, this SCR is a rated breakdown voltage of V2, similarly V3 and V4. Okay. When we have to connect a SCR in a series, one thing which we have in the mind is that the breakdown voltage of all the SCR must be same. That means if the breakdown voltage of first SCR is V1, then we have to select a SCR which has the same breakdown voltage which is equal to V1, which is given as 600 volt. Therefore, the efficiency is equal to 33 upon 36, which is equal to approx 91.7%. That means, what is this 91.7%? This 91.7% symbolizes that the individual SCR is operating at its 91% times of its breakdown, voltage breakdown. Suppose that the voltage breakdown of an individual SCR is equal to 600. Then what amount of voltage it can bear right now is equal to 600 times of 91.7%. This is known as string efficiency. The total voltage of all SCR connected in a series, that is the total voltage applied to a system, to the number of SCR which are connected in a series, and the rated value of individual SCR, the rated breakdown voltage of each SCR is known as string efficiency. Now we see that each SCR is worth for 91% of its breakdown voltage. To improve the reliability of each SCR, we can increase the number of SCR, and this reliability is known as derating factor. Derating factor means we minimize the voltage across each SCR of its rated value, and the derating factor can be calculated as 1 minus string efficiency, which is equal to 1 minus 0.917, which is equal to 8.3%. 8.3%. If we have to increase the reliability of each SCR, we have to increase the number of SCR. In this given example, in first case, we have 6 number of SCR. That means the total voltage can be beared by 6 number of SCR in our first case. If we have to increase the reliability of each SCR, we can implant a new SCR. Suppose now the SCR connected are 1, 2, 3, 4, 5, 6, 7. That is the N is equal equal to 7. Then what is the efficiency? Then in this case the efficiency is equal to 33 upon 42 is equal to approximately 71.7, and in this case the derating factor is equal to 1 minus 71.4%, which is approximately equal to 28%. Now what is this 28%? Now each SCR does not have to bear 600 times of 91.7 times of 600 voltage, but it has to bear the 28% of its voltage. What does this mean? If a SCR has a breakdown voltage of 600 volt, suppose a SCR has a breakdown voltage of 600 volt and 6 SCR are connected, then each SCR has to bear a voltage of 0.918 times of breakdown voltage. Now if we increase the number of SCR, as soon as we increase the number of SCR, then each SCR has to bear a 0.714 time of its voltage, which improves the reliability of SCRs. The problem related to a series operation. When several SCR are connected in series with a system, there is a problem of unequal distribution of voltage across SCR. What this means is unequal distribution of voltage across SCR. Suppose a similar set of SCR are connected in series across a system that is 300 volts suppose. Then for reliable operation or 100% operation, each SCR have to bear 100 volt. But it is not possible because of static IV characteristic of SCR and dynamic characteristic of SCR. When the SCR are manufactured, all the SCR don't have the same static IV characteristic. That means this SCR has different IV characteristic, this SCR has different IV characteristic, and this SCR has different IV characteristic. So here is an example how the unequal distribution across SCR is occurred. Here in this example I consider a two SCR, first one SCR and this is a second SCR, and this graph IV characteristic shows the IV characteristic of SCR1 and SCR2. Now this I0 is our leakage current. Leakage current when SCR is in forward blocking mode, this I0 is flow from the SCR. Now see here, for V2 which is SCR2 and V1 is a SCR1, V1 and V2 are the forward blocking voltage of SCR1 and SCR2. Now see here, for a same leakage current, the voltage of the breakdown voltage of SCR2 is less than the breakdown voltage of SCR1. For same I0, V2 occurs very early while V1 occurs after some time. Suppose that your leakage current is of 2 milliampere and the breakdown voltage of V2 is 30 volt while V1 is equal to 60 volt. What this happened? Why this happened? Because there is an unequal distribution of voltage across SCR, which is shows here. For same value of leakage current, SCR suffer a 30 volt voltage while SCR1 suffer a 60 volt voltage, which shows the unequal distribution of voltage across the SCR. Why this occurred? Due to a different IV characteristic of SCR. So how it can be removed? How the problem of different unequal distribution of voltage can be removed? It can be removed by using connection of SCR, connection of resistor across SCR. Just connect a resistor across each SCR like this. Connect a resistor across here, connected a resistor across this, connected a resistor like this. This is R. Now the value of this resistor must be same such that the equivalent resistor of this SCR and R is equal for all the SCR. Suppose this is equal to 100 ohm, this is equal to 150 ohm, this is equal to 20 ohm. Then the combination of this and combination of this must be same. That means the equivalent resistance of SCR and R must be same for all SCR. But this cannot be achieved because we have to analyze each and every SCR, and from this analyzation we have to select the value of resistor, which is a time-taking process and very difficult. So we have to select an optimal resistance for this method. This optimal resistance can be calculated by now there are SCR1, which are the leakage current of IBN. IBN is a leakage current of SCR1, and the SCR2 is a combination of N-1 SCR, and it is a leakage current of IBMS. It is a maximum leakage current of N-1 SCR. Now when we apply a voltage across this combination, then the total voltage Vs is equal to the voltage across this combination and the voltage across this combination, which is equal to I1 into R plus N-1 I2 into R. The voltage applied, the total voltage is equal to the voltage across this thyristor 1 and the voltage across N-1 thyristor. Now the total I1R can be written as the total breakdown voltage of SCR1. I1R is equal to total breakdown voltage of SCR1, which can be written as VBN. So I1R can be written as VBN plus N-1 into I2R. Now I2 can be written as this I2, apply a nodal here. If we apply a nodal here, then I2 is equal to I minus IBN I1, we have to written this I1 in the terms of I1. This current I, we have to written in the terms of I1. Therefore, I is equal to I1 plus IBN. This I can be written as I1 plus IBN minus IBMX into R, which can be further written as VBM plus N minus 1 I1 minus IBMX minus IBN into R, which can be further written as VBM plus N minus 1 I1 minus. This is a maximum leakage current and this is the minimum leakage current. So we can write as del I into R. Now Vs is equal to VBM plus NRI1 plus R del I. Vs is equal to VBM plus NRI1 plus R del I. So resistance R can be written as VBM minus Vs upon N minus 1 into del I. This is the optimum value of resistance. This is the optimum value of resistance which must be connected across each SCR for neutralizing the non-uniform voltage distribution across each SCR. Now the second method used for unequal distribution of system is due to different dynamic characteristics. Dynamic characteristics are the condition of different turn on and turn off time. Now suppose we have to consider two thyristors which are connected in series with a voltage Vs. If these two thyristors have a same turn on time, that means if this thyristor is turned on at suppose 2 seconds, then this thyristor must be turned on 2 seconds. Then the voltage distribution of the voltage distribution across each SCR is equal to Vs by 2 and Vs by 2. Now, if the turn on time of one SCR is higher than second, suppose the turn on time of SCR1 is 2 milliseconds and turn on time of SCR2 is 4 milliseconds. Then what happens? As soon as the voltage is applied after 2 milliseconds, SCR1 get turned on. SCR1 get turned on, that means it behaves as a short circuit, while the SCR2 is open circuited. So whole supply voltage is appear across this. This shows the unequal distribution of voltage because across SCR1 the voltage is 0, while across voltage across SCR2 is total voltage Vs, which show the unequal distribution of voltage due to a different turn on time. Due to different turn on time, the voltage across SCR1 is 0, while the voltage across SCR2 is the total supply voltage, which is equal to Vs. Now this same happens when during the turn off time. Here a turn off time of thyristor 1 is T1, while the turn off time of thyristor 2 is T2. See here. This is the time T1 when thyristor SCR1 get turned off, while this is the time when the thyristor 2 is turned off. So this excess carrier, the excess charge carrier which are in the SCR have create a voltage which is equal to del Q by C. Because when the thyristor is turned off, this whole system will behave like a capacitor. To remove this different dynamic characteristic of SCR, we have to connect a capacitor across SCR. We have to connect a capacitor across each SCR like this. Here thyristor 1, here thyristor 2. We have to connect a RC, which is a bypass resistor, capacitor and a diode. Similarly for this system, RC, capacitor, diode. The value of this capacitor, the value of capacitor is chosen such that the total capacitance, this is a self-capacitance is the capacitance of a thyristor, self-capacitance is a capacitance of thyristor. So the value of this capacitor is chosen such that, the value of capacitor is chosen such that the total equivalent capacitor, the total equivalent capacitor must be same. What does this mean? The combination of this capacitor which are connected across the thyristor and the self-capacitance of SCR must have the same value for each combination. Must have the same value of each combination. So this C is equal to N minus 1 del Q upon N VBM minus Vs. So, what is the problem with the series operation? The unequal distribution of voltage. The unequal distribution of voltage occur due to two types. First one is due to a different IV characteristic which can be removed by connecting a resistor across the SCR, and second one is a difference in the dynamic characteristics such as different turn off time, different turn on time, which can be removed by a connecting RC system across the SCR. Therefore, the total protection of unequal distribution can be designed as suppose this is thyristor 1, this is a thyristor 2. We have to connect a resistance R which is known as equalizing circuit. Resistance R is an equalizing circuit, and a combination of RC diode and capacitor, RC diode and capacitor, RC diode and capacitor, RC diode and capacitor. This whole combination is used to minimize the unequal distribution of voltage. This part is known as dynamic system because it deals with the turn on and turn off process, while this whole part is known as a static system. This is all about the problem related to the series operation.
Shambhunath Group of Institutions, a mentor for glorious transformations.